正所謂一生人最重要嘅3件事，就係食得、屙得，同埋最重要嘅係瞓得。有瞓覺問題嘅你，我想喺度借住我呢個天賦，一把容易令你入睡嘅聲音，每晚會喺呢度呢，同大家分享一段嘅新聞，一段嘅書，又或者其他嘅文章，令到你哋可以好快咁瞓得着。
Alternative processes. Hannon recently co-wrote a paper in Energy and Environmental Science proposing a chemical alternative to calcining. Rather than wrenching CO2 away from calcium carbonate at high temperature, he proposes reacting the mineral with sodium hydroxide at room temperature and pressure. This produces calcium hydroxide, which can be used to make clinker, and sodium carbonate, which locks in the CO2 rather than releasing it. At the moment, the technique is not as clean as it appears because sodium hydroxide production is very energy intensive. That could change if we use green electricity, says Hannon. A similar process, though carried out mechanically, has been proposed by researchers at Johannes Gutenberg University in Germany. In a paper in Advanced Functional Materials, researchers have proposed combining calcium carbonate and sodium silicate in a high-impact ball mill. This avoids the need for calcining with its high energy input and produces an intermediate compound that can be used in cement production. Again, the CO2 that is released during calcining is trapped within an inorganic mineral. Solid-state reactions like this can be confusing to non-chemists, but Wolfgang Trimmel, professor of chemistry at JGU, explains that it is achieved by reducing particle size and increasing surface area. This, combined with heat products in the mill, drives the chemical reaction forwards. So far, we've only done this at small scale, says Trimmel. The challenge now is to make it work at a larger scale. I think any patent that succeeds will have to set up the process to make cement at scale in this way, he says. Although the cement industry uses ball mills widely, he says they typically do not reduce particle size enough to allow the type of reactions he describes. The mills don't have a high enough impact. Trimmel says that milling is gaining increasing use as a green technique in the chemical industry, as it can help to avoid the use of solvents. This, he says, may help to drive its adoption in other industries such as cement, but it will take time. Doing this on a technical scale would take many years and would not provide a short or medium-term remedy for CO2 emissions, he points out.